Greetings and welcome, Cameron. We are going over last night's quest, example 3. Some of you guys have this spreadsheet open, which, make a copy of it. It's amazing. We've actually got some of these problems already predefined out here for you. You're welcome. Actually, I think it's just these two. So let us take a look at this. It says the frequency table, all right, also known as a frequency distribution, shows the number of hours that students volunteer per month. Display the data in a histogram. What was a histogram? It was like a bar graph, except what? Histograms didn't have spaces between the bars. All of them measured the same type of thing. So instead of like favorite colors or favorite numbers, all of them measured like the same thing numerically. So you can put the coin away, thank you. So just let's make a display of this as a histogram. So here's my table. Watch this. So I'm going to draw some lines. Here we go. Ooh, I'll start with that one. Actually, that's pretty perpendicular there. So, ladies, gentlemen, silencio. All right, so here we go. So how many groups do I have? These we call the bins. Other times they'll be called classes. 1, 2, 3, 4, 5, 6, 7. So let's make 7. 1, 2, 3, 4, 5, 6, 7. And here's like the 1 to 2s. Here's the 3 to the 4s. Here's the 5 to the 6s. 7 to 8s. That sounds pretty good. 9 to 10. 11 to 12. Question. I don't know. That's pretty good. That's pretty good. So guys, check this out. Why did I choose to make my Y scale this high? Because the highest value I saw was 20, and that doesn't mean that the students volunteered 20 hours. That means that there were 20 students that volunteered between 7 and 8 hours per week. Okay? So I actually don't know. Maybe all of these were 7s. Maybe only one was 7 and then a whole bunch were like 7.5. I actually don't know these actual values. I just know 20 of them landed within that grouping. So let's make this. So in the 1 to 2 range, we had 1 student. In the 3 to 4 range, we had 5. Follow along, please. Yeah, don't do that with that calculator. 5 to 6 range, we had 12, so I'll go up to 12. 7 to 8, we had full 20. What? And then we had 15 for the next one. And yeah, so I just make like this bar graph where the widths of the bars are the widths of the classes. And then we got saving. Yeah. Well, in the 9 to 10 range, there were 15 for the height. Yep. Okay. So so the heights of these bars are the frequency that those numbers within that range occurred. Let's see how risky I can be. Can I paint it? Hey, it worked. Hooray! So the height of the bar literally represents, right, the number of students that landed in that range. So this was, yeah, should have been 5. It looks like it was a little higher. This was the 12. Here was the 20, 15, 7, and 2. So there's my frequency distributing. Classic. It says, describe the shape of the distribution. Yep. I mean, it's not symmetric perfectly, but it's kinda normally distributed. A little bit. Right? It looks distributed. Wait a minute, guys. Why am I okay right now? Distributed. There we go. Right? It's got a bell shape to it. I can't spell bell either. right? There we go. So that's kind of the general shape. It's not skewed left or right, and that's how we would describe that outcome. Okay? Now, let's actually take a look at the spreadsheet here real quick. So I've got these classes here, 1 to 2, 3 to 4, 5 to 6, 7 to 8. Now, gentlemen, stop playing with each other. Thank you. Be quiet and follow along. So now notice this. I actually have all of these cells grayed out for us. So I can actually change just the beginning cell, and then all of those change as a result. Okay? So I've got that. And then I can also change the bin size. So notice I can actually change how big each bin is. And in our case, our bin was 2. And I've pre-programmed the frequency like so. So let's highlight this. And I think if I go to Insert Chart, let's see. Ooh, that's pretty good. That's pretty good. I think I pick usually this this stacked one sometimes, but that might actually be when I select this and that. Nope, not. There we go. I got to hold Control to select 2 columns that are non-adjacent to each other. So Insert Chart. Let's see. So chart types. I'm going to pick this stacked column chart, and I'm going to use column A as the labels. And I get something that's pretty close. You can actually fidget with this a little bit. It's actually a little bit tricky to try to get the bars to actually just be the width that you want them. But I can get pretty much the same idea as the one that I made here, right? Same idea, right? So, and then you can actually even change the Y scale and all sorts of things like that too. So there are ways of getting spreadsheets to make frequency distributions as well as histograms. There's some better stuff out there than this as well. I'll actually even show you a Desmos later, perhaps. Okay, question 5. It says, describe the shape of the distribution of the data. So a stem and leaf plot, you have to know what the key means. So the stems were all the tens place, tens, and the leaves were all the ones places. So a 3-bar 1 represented 31. What does this 2 mean then? That would mean 42. What? Wait a minute. Why do I have 2 1s here? What does that mean? So there's an 11 and 11. So 11 showed up twice. So looking at this, you could actually try to figure out what the mode was. What do you guys see as the mode here? Now, what about all these 4s? Does that mean that 4 was the mode? No, because what was this for? That was a 14, this was a 24, and this was a 34. So I think 11 would have been our mode there, yeah. So a stem and leaf plot, it kind of behaves like a frequency distribution where these classes were, right, this was 10 to, right, 19. This would have been like 20 to 29, kind of, except instead of having the frequency, I actually know what these numbers were. But if I look at how many there were, I know that there were 5 numbers in the tens range. Okay, so I can kind of tell a little bit more than a frequency distribution. Now, if I want to find the shape of this, notice this. This was my trick yesterday for you guys. I said just kind of take this like so and turn it on its side. Well, think about this. Yeah, in terms of my distribution, it looks like this. So the data is mostly on the left side, which means it is skewed right, which almost feels like the opposite of what I'd want it to be. But the skewing has to do with the tapering that happens in this direction. It was also what a positively distributed graph was one way to think about it, because like positive is over here, negative is over there. Yeah, also they called this a tail over here. Yeah. So anyways, so the graph is skewed right because the data is packed on the left. Let's see, do I have time for one more? Determine which measures of center and variation best represent the data. Okay, so looking at this, what do you guys think about this distribution? Is it skewed or is it bell shape? It looks like it's a little bit packed to the right here. So this is skewed left, right? There's a tail on the left side here. So the mean might have been something like this, let's say. Maybe this was your mean. And whenever the graph was skewed, we actually, instead of using the mean as the center and using standard deviation, we actually preferred to use a median. A median kind of better represented this. So we will use a median, and in terms of how to measure the variation, we would use a box and whisker plot. Box and whisker. Yes. Excellent. That's good enough. All right, and all right. Surprise, surprise. Yeah, you know where they are. Let's see. Do I not have example 9? I don't have the data for example 9, guys. But I thought I did this. Mr. Waddy, you must have been too sick yesterday to know what was going on in reality. So sad. So guys, check this out. Let's make a new sheet. I did that by using the plus sign here. A little plus sign in the corner. Add sheet. Actually, you know what? Cancel that. I'm going to delete that. I'm going to duplicate a sheet. You heard me. What one do I want to duplicate? I think I want to duplicate this one. So click on example 2 and duplicate it. All right. And now I've got a copy of example 2. We're actually going to rename that 604 parentheses 9. You guys tracking with me? Either follow along or do this as well. Definitely don't distract one another. So for example 9, they want a histogram using 7 intervals beginning with 26 to 50. So if I want to begin at 26, I'm going to write 26 right here, like so. And 26 to 50, I want my bin size, looks like, to be 25. So I changed the start and I changed the bin size. And notice now I've got my class 26 to 50, 51 to 75, 76 to 100, 101 to 125. What is this third column over here I called class mark? How do these numbers relate to these other two numbers? Sorry, what was that? Not quite. Yeah, how does 63 relate to 51 and 75, or 88 relate to those two? It's actually the average of those two numbers. The class mark is kind of the middle of those two things. And so now I've got that set up. The only thing I've got to do is change my data. So watch this. So I delete the data that was in there. And let's see how good I can Alt-Tab. You guys ready for this? Get ready for my speed data entry. Actually, I saw a video of this guy doing like inventory at a 7-Eleven, and he was like speed doing data entry on this little side holster machine. It was amazing. I'm not going to be as good as that. So here we go. 120, 60, 150. 120, 50, 160. Did I do that right? Yeah. 120, 30, 60. Then I've got 170. You got to call it 100, by the way, friends. 100, 40, 80. And notice as I'm typing these, it's actually auto-calculating these frequencies, which is kind of cool. 60, 50, 200. All right. 150, 40. All right. 70, 80, 50. And 175, 50, 30. Entering data is the most entertaining thing on the internet. All right, there we go. So I entered that data. It looks like I've got a decent number of them. And this actually automatically figured out the frequency distribution. These were actually, I programmed this. I wasn't going to make you do it. But it actually has a little count if, and it finds out how many are bigger than 26, but less than or equal to 50. Actually, I said that opposite. Greater than or equal to 26, but not up to 50. Everything up to 50, not including it. So that was the less than sign. Yeah, so that was kind of cool. Yeah, and then it counted that automatically. And now I could actually make, if I select this and this, I could insert a chart. There's my chart. Let's go to chart types. I find the stacked column chart, and I change it to use column. No. Oh dear, I selected that in the wrong order. That's interesting. You done got me, spreadsheet. I gotta highlight this first, and then this. How do I select columns that are apart from each other? What am I pressing? Control. Man, good job. That's right. You should make like a YouTube about spreadsheets. Make your own channel. Seriously, I watch those all summer long. I'm just like, teach me about spreadsheets. Okay, so here I get my outcome. Now, this class was the 26 to 50 class. I guess I can leave it kind of like that for now. But here we go. So there's my frequency distribution. You could have done that by hand as well, but I want you to be able to know both. How to do it by hand and how to do it analytically. It says, which measure of center and variation best represents the data? Well, what does the data look like? Is it bell-shaped or is it skewed? It kind of looks skewed. Which way is it skewed? I got it. Which way? Data is dense at the left, but it's right. It's the opposite. You done juked me, John Madden. So let's see. It's skewed right. Okay. And because it's skewed, what do I want? Do I want the mean or the median? We actually have this data. Let's do it. I'm going to hit insert here. Here's my nice little chart. Ooh, you can drag it around on the spreadsheet. I have the data. Let's find the mean. Mean. All right, how do I find the mean? In spreadsheets, I just write equals average, average, and I want to select my data. Watch this. If I hold shift, I can select multiple. If I hit shift and control and then down arrow, watch this move. Pro tip. Oh, man. Bam! It jumped to the bottom of the list. You can't believe it. Imagine if that was like 1,000 or 20,000 long. I just hold shift, control, and then hit up or down, and it'll automatically jump to the bottom of that list. That's so great. So the mean is 87. What's the median? Actually, I don't have a way to find the median, do I? They do have a median. There might also be like a quartile function that also would have worked. So I'm going to use median. I'm going to select this, hold shift and control. Bottom of the list. All right, man, that was so great. You guys are so pumped about spreadsheets. So because the data is more densely packed, instead of 87.29, 87.29, all right, that's the mean. We also call that X bar. I'm going to use the median, which was 75. All right, looks more like this, I guess. Median. All right, and the median represents more of the data accurately than the mean does. So when it's skewed, you use the median, right? So we would use the median. All right, and in terms of variation, we would have done a box plot. I'll just call it box plot this time because it's skewed. What's this final question? This video is getting long enough. The bank charges a fee for any ATM withdrawal less than $150. How would you interpret the data? So when is the bank charging their fee? Kind of like for all of these people, right? And they don't charge a fee for these numbers. What about here? What if I look at my distribution? It's going to be 1. Here, let's actually do this. Taking a screenshot so I can analyze data. Are you guys pumped about Data Week? This is so cool. All right, so 150 or less. How could I add these up? Let's see, 8, 12, 17, 20, 21 out of a total of 23, 4. So 21 out of 24. So they're going to charge fees for 87.5% of the transactions they'll charge a fee for. So there you go. Thanks for watching, Internet friends. Adios.